Okay, let's keep learning about ionic bonding. The first thing I want to talk about is why electrons move from sodium to chlorine and not from chlorine to sodium. Okay, so in the first step of ionic bonding, this one electron from sodium moves over here to chlorine to fill this one space. But people often ask, why couldn't these 7 electrons from chlorine move over and fill these 7 empty spots in sodium? Well, that's a great question. The answer has to do with a topic called electronegativity. Okay? Electronegativity is a measure of how badly an atom wants electrons. The higher an atom's electronegativity, the more greedy it is for electrons, the more it wants to try to steal them from other atoms. So in ionic bonding, there are electron givers and there are electron takers. This has to do with whether an atom is a metal or a nonmetal. Okay, so nonmetals, like chlorine, all have a very high electronegativity. Okay, they are very greedy. They want other electrons very, very badly. On the other hand, metals, like sodium, have a low electronegativity. Okay, they're not so greedy for electrons and they're willing to give them up. So that's why electrons move from sodium to chlorine and not the other way around. They move from the atom with low electronegativity, low greediness, to the atom with high electronegativity. And this is the way it always works in ionic bonding. The metals, like sodium, are the electron givers, and the nonmetals, like chlorine, are the electron takers. Electrons always move from the metal to the nonmetal. And in ionic bonding, because of that, the metals always become positively charged because they lose electrons, and the nonmetals always become negatively charged because they gain electrons. It's all about electronegativity, the greediness of an atom for electrons. Now I want to talk a little bit about the shape and structure that ionic compounds make. Okay, so we've got sodium here, we got chlorine here, and we've talked about how they get opposite charges and they end up sticking together, forming a shape kind of like this. Okay, but so far we've only talked about 2 atoms, one of each. In nature, rarely would we find just 2 atoms. Okay, usually there are going to be a lot more than 2 atoms that want to exchange electrons and combine together. So what happens when we have a bunch of atoms that could all do ionic bonding? Okay, well, what you might want to think of is each pair of these atoms could form a structure kind of like this. Okay, but here's the thing. These guys wouldn't stay separate. Okay, this is super important. They wouldn't stay separate because opposite charges attract not only in groups of 2. Okay, so this positive and this negative, they're attracted to each other, but this positively charged sodium will also be attracted to this negatively charged chloride over here. Okay, so these 2 things are going to end up connecting to each other because of that attraction, right? And then there's this guy over here, and this positively charged sodium could be attracted to this negatively charged chloride, and this negative charge could be attracted to this positive charge. So this will come together just like here. Okay, and so we start building a much bigger shape. If we get a bunch of these sodium and chlorine atoms getting charges and coming together, we're going to end up with a shape like this. This is called a lattice structure. Okay, and you can see how these ions are packed really closely together and how they're making this larger shape. Okay, here we have a negative ion and it's surrounded by 4 positive ions because they're all attracted together. Okay, and over here we've got a positive ion that's surrounded by a whole bunch of negatively charged ions. And just in general through the lattice structure we alternate plus, minus, plus, minus, plus, minus, because all of these opposite charges are attracting together to make this lattice structure. So the important thing to keep in mind is that ionic bonding, when you're talking about more than just 2 atoms, it doesn't only make these small groups of two, but these groups are going to be attracted to each other, and they are going to make much bigger structures that are going to become these lattice structures. So that's super important when you're thinking about the structure of ionic compounds. Now, as we go forward, we'll probably continue focusing on just two atoms at a time. But whenever you see a shape like this, keep in mind that it's just one part of a bigger lattice structure that you get when a whole bunch of these different units come together. Okay, finally, let's just talk naming really quickly. Okay, so when this ionic bond forms, we start with sodium, Na, and chlorine, Cl. Okay, sodium loses one of its electrons to chlorine, so that gives us a sodium ion, which we can abbreviate as Na+. And since chlorine gets an extra electron, it becomes a chloride ion, Cl-. Okay, now we call it chloride because chloride is the negative version of chlorine. It becomes a negative ion and it becomes chloride. Sodium, on the other hand, we call it sodium whether it's neutral or whether it's positively charged. So we have a positively charged sodium, negatively charged chloride, and they stick together. So now they make a compound because these two things have connected, okay? And the compound, we call that sodium chloride, and we write its chemical formula as NaCl. Now, here's one common mistake that people make that I don't want you to make, okay? They're writing the formula for sodium chloride and they see that this has a positive charge and this has a negative charge. So often they'll write it as Na+, Cl-. Now that's not right. Don't do it. Okay, it's true that sodium does have a positive charge and chlorine has a negative charge here. But when the two of them come together, the positive and the negative charge, they cancel out. So it's like the whole thing combined doesn't really have any charge anymore. So that's why we don't put the plus and the minus when we're writing the chemical formula. It's just NaCl. We leave out the plus and we leave out the minus. Okay? One other thing that sometimes happens is when people are asked to name this compound, okay, so like the name sodium chloride, they try to keep these charges in. So they call it sodium plus chloride minus. And again, you don't want to do that because we don't keep the charges. So don't call it sodium plus chloride minus. It's just sodium chloride, NaCl, even though these atoms still have a charge. Because they're like balancing each other out in this compound, we don't worry about the charge when we're naming it.